So for the page 6 of the memory allocation notes, we're going to work with the handout from Learn. So I'm going to go into Lectures and Handouts, and I just added this one today. It's static allocation. I'll download it. Okay. Before we get into the details of the static allocation, let's go down to the main. If we look at the main, we initialize the kernel, ignore the mutex attribute for now. We allocate a mutex, ignore the thread attribute for now. We allocate a thread, and we start the kernel. So let's look at the thread. There it is at the top there. It acquires a mutex, it prints hello, and it releases the mutex. And that's the whole thing. So a very trivial application. I didn't even put that into a while true loop. So now let's go up to the top. So as the name says, it's an example of static memory allocation. So we've got the usual SimSys OS2 header for all the OS stuff, and I've included a new one. So SimSys OS2 contains all the headers related to the RTOS2 API, the Application Programming Interface. RTX_OS includes stuff that's specific to the RTX5 implementation of that interface, and we need it in the code down here. So this is the API stuff, and this is the implementation stuff. So RTX5, and we need something that's defined in there. So we're going to statically allocate the stack for the thread, and so the stack is going to be 2048 bytes, or 2 kibibytes. Another way I could have defined that would have been to do this one. Let's make it an unsigned long, and that's 2 to the power 0. 2 to the 48 is 2 to the power 11, so I could have shifted it left by 11, and you'd put all that in brackets, and that would have worked too. Okay, so now we are creating a couple of control blocks. So this is going to be the mutex control block, the thread control block, and then here is the storage for the stack. And these are all globals, right? Because they're defined outside of any functions, and so they will be in the data segment. So they'll be loaded when the program is loaded into memory, and they'll be initialized then. So let's just look at what's being used here. So we have OS RTX mutex control block size, and this is defined in that rtxos.h. That's why we included it. So that gives us the size that we want to allocate. So why not just do a uint8 type mutex control block and just make it that size? Why are we dividing by 4 and making that an array of uint32 types? And the answer is right here. We want it to be 4-byte aligned. So using this trick, making it an array of 4-byte or word-sized objects means that they will be aligned to a 4-byte address. An address is the starting address is a power of 4. So we do the same thing for the thread control block, and for the stack it needs to be 8-byte aligned. And so if you look on the left there, we're allocating an array of uint64 types, and those are 8 bytes. So that's 8 bytes, whereas uint32 types is 4 bytes. So since we're doing an array of these 8-byte objects, we need to divide the stack size by 8 to get the correct amount of storage. And again, that'll force it to be double word aligned in memory. which is required for stacks on the ARM processor. So next we see the OS mutex ID type. There's nothing different about that. So now let's go back down to our main. So let's look at the mutex attribute that we're defining down here. So this is a type that is defined in one of the SimSys2 header files, and probably the SimSys_OS2 header file. And it's actually a struct, and we can use remember this is a designated initializer, and so we want to tell it what memory to use for the control block. So the control block memory is going to use the storage that we declared up above there, the mutex CB, and the control block size, we can just use that same definition that we used above, and then we can pass that attribute, a pointer to that attribute, when we're creating mutex new. So that mutex for its control block will use that storage that we told it to use. That's going to be in the data segment, so it won't be allocated from the heap. And then likewise for the thread attribute type down here, we are telling it that the control block needs to use the storage, so we're passing the address for the storage that we allocated above, and we tell it the size of that, and then we also are telling it which memory to use for the stack and how big that is. And then we pass that, a pointer to that attribute, to the thread. Remember, worker is the function name that's going to execute. Null is the argument to pass to that function. In this case, just null is not being used. And then the thread attributes. And that is an example of static allocation. Nothing here will be allocated dynamically at runtime. So we will have deterministic execution. It will always behave the same way, which is what we want. So that's the end of that example. And I forgot to number this. So this is page 6, last page of the memory allocation section.